Okay, this problem right here is from section 7.2, page 378, number 43. It reads, steel rods are manufactured with a mean length of 25 centimeters. Because of variability in the manufacturing process, the lengths of the rods are approximately normally distributed, with a standard deviation of 0.07 centimeters. Part A states, what proportion of the rods has a length less than 24.9? But first, what we look at is the fact that it's a normal distribution, so normally distributed. There's a function on the calculator that helps us solve that. But first, we look for our mean, which is 25, which was given, and our standard deviation of 0.07. Next, what we do is we look at, where's it at? We look at what are we looking for? So we're looking for something that is less than 24.9. So when we do this, we have to put it into the calculator. Use the normal CDF function, which helps us solve it pretty much, which is basically lower bounds, upper bounds, mean, and standard deviation. Then this is what we get. So for the lower bounds, we get negative 9999999, which is we're looking for something less than. So because there's no infinity button, we just do it all the way down to the biggest number, so just 9999. The upper bounds would be 24.9, the mean 25, and standard deviation 0.07. And what we get is we get approximately 0.0766 rods. That's for part A. Alright, now we go back to part B. Any rods that are shorter than 24.85 or longer than 25.15 are discarded. What proportion of the rods will be discarded? So for this part, it's basically the same thing. So we look at a number between 24.85 and 25.15. So basically we're looking for something that is going to be greater than this number and less than this number. So I drew out a little diagram looking for what part are we looking for. We're looking for this little shaded area right here. So we do it again, but this time we're going to use this number as our lower bounds and this number as our upper bounds. And mean stays the same, standard deviation stays the same. We should get 0.9679. But because this number is giving us the whole thing, we have to subtract it by 1 to look at just this little portion of the graph. And we get 0.321. So approximately that's what we get for part B. Okay. So for part C, we're using the results from part B. If 30,000 ball bearings, wait, is that the right one? Nope, wrong one, sorry. Where are we at? Oh, right here. Using the results of part B, if 5,000 rods are manufactured in a day, how many should the plant manager expect to discard? So basically all we do here is we get the 5,000 rods and we multiply it by this number. This number, which will give us approximately 165, we round it up, we get 161. So 161 rods are going to be the ones that are going to be expected to discard. Okay, lastly, we go to part D. And an order comes in for 10,000 steel rods. How many rods should the plant manager manufacture if the order states that all rods must be between 24.9 and 25.1? So this is basically the same thing that we did up here, but with different numbers. So we get our normal CDF, which is 24.9 for our lower bounds. Our upper bounds is 25.1. Mean stays the same, 25. Standard deviation still the same. We punch it into a calculator and we get roughly 0.84687. So what we do now is, since the order was for 10,000, we just divide that number for this by this number, the number that we originally got. So we get roughly 11,808. And that's pretty much it.